Let's now go over the laws of exponents or the properties of exponents. That's the next thing I want you to become very fluent with, how to manipulate exponents. All right, so first property, so we have 10 properties here. You're supposed to know all of these properties by heart, but really once you use them all the time, they're not really hard to remember. So first property, anything to the 0 equals 1. Anything to the 0 equals 1, and anything to the 1 does nothing, gives you the same thing back. So a to the 1 equals a, and a to the 0 equals 1. Any number to the 0 equals 1. Second property, having an exponent of -1 means you flip. So a to the -1 means 1 over a. And of course, a cannot be 0 because you cannot have 0 on bottom. Um, so if a is 0, it is not defined. It doesn't make any sense. But a to the -1 is 1 over a, it's a reciprocal. If you have two exponents like that, two variables with exponents, the variables have to be the same, and then you can simplify that. So if you have a to the m and a to the n, then that is equal to a to the m plus n. So you add the exponents. If you're multiplying two powers that have the same base, then you add the exponents. If the bases were not the same, so if you had something like a to the m times b to the n, and then you cannot do anything there. There's absolutely nothing to do there. You cannot simplify that at all. Okay, so the bases have to be the same. If the bases are the same, you can simplify that by adding the exponents. Okay, then if you have two exponents back to back like that, uh, a to the m to the n, then to simplify that, you multiply the exponents. Okay, so for example, real quick, you have 2 to the 3 to the 4. That would be the same as 2 to the 12 because you multiply 3 times 4, which is 12. So if you have exponents back to back like that, you multiply the exponents. The way you would add them when they're like written separately like that. Oops. If you had 2 to the 3 times 2 to the 4, then that's another story. In this case, you add them. That would be 2 to the 7. So they have to be written completely separate like that. If it's just one power back to back with another power, so one exponent followed by another exponent like this, then you multiply them. If they're like separate entities like that, 2 to the third times 2 to the 4, then in that case you add them, 2 to the 7. Okay, next property is if you have multiplication inside of parentheses, then you can distribute to the exponent. So, like that, x, y to the 4, that's the same as x to the 4, y to the 4. And that's only when you're multiplying things. If that was the sum, you cannot do this. This is absolutely not the same thing as x to the 4 plus y to the 4. You cannot distribute the exponent when this is a sum or a minus. You can only do that when everything is being multiplied, or if it's a division. That's another property that we're going to go over in a minute. But you can only do this if it's multiplication or division. If it's a plus or a minus inside of the parentheses, you cannot distribute it. Okay, and that is a very common mistake. You cannot do that. It is so common that it has a name. It is called a freshman's dream. Freshman's dream mistake. Freshman's dream. Oops. Okay, you cannot distribute exponents over sums or minuses. That's completely wrong. Don't do that. But over multiplications, that's correct. So if you have a multiplication inside, you can distribute it. or a division, which I said was the next property. If you have a division, you can distribute it as well. So if you have a over n to the n, you can distribute that and say the numerator gets the power, the exponent, and the denominator also gets the exponent. So you can distribute over a division. Next, if you're dividing two powers that have the same base, then you can simplify that by subtracting the exponents. So, quick example, x to the third over x to the 2, and that would be x to the 3 minus 2, which is x to the 1, which is x. So if you have two powers and they have the same base, then you can simplify that by subtracting the exponents. Okay, here's another one, x to the 7 over x to the 4. That would be x to the 7 minus 4, which is 3. So you subtract the exponents. If the bases were not the same, so if you have something like this, x to the 7 over y to the 4, then you cannot do anything with this. This is like dead end. You cannot simplify that. It's over. It has to be the same base. Okay, then if you have a negative exponent, like that, a to the negative n, that is the same as flipping and then keeping the exponent on the bottom positive. So, for example, x, concrete numbers, x to the negative 3, that would be the same as x 1 over x to the 3. So you flip and you keep the same exponent, but positive. Or x to the negative 10, that is the same as 1 over x to the 10. So you flip and you keep the positive exponent. Okay. If you had a negative exponent that is affecting or is being applied to a fraction, you can flip the fraction and get rid of the negative sign. So if you had x over 4 to the negative 3, that would be the same as flip and keep the positive exponent. So if you have a negative exponent affecting a fraction like that, you can flip and keep the exponent but positive. Okay, so then basically the negative part of that exponent tells you flip. So if you apply that negative part, you flip, and now you already did the negative, so the negative goes away because you just applied it. You did it, so you don't need it anymore because you did it. So negative exponent means you flip. All right, and lastly, if you have a fraction like that, you have negative exponents either on the top or on the bottom, then they basically migrate. You see, you have, for example, in this one, b to the negative m. It's on the bottom right now, so you move it to the top and keep the exponent but positive. And then if it's on the top, you move it to the bottom. And we're going to do many examples like this. So basically, if you have negative exponents in a fraction like that, they migrate. They trade places. So either if they're in the bottom, they move to the top. If they're on the top, they move to the bottom, like here. A is on the top, he moves to the bottom. B is on the bottom, he moves to the top. Okay, so we're going to do multiple examples of that. But before we get to the examples on how to use the properties of exponents, recall really quick how to compute exponents if you were doing it by hand. Um, so for example, 2 to the 4 would mean 2 times 2 times 2 times 2. That means you multiply 2 by itself 4 times. Okay, so that's what the exponent means. And then one more last reminder: you should know what is the order of operations. The order of operations, I'm sure you probably have heard this. PEMDAS Please excuse my dear Aunt Sally. That is a mnemonic that helps you remember the order in which you are supposed to carry out arithmetic operations. You simplify parentheses first, then you take care of exponents, then you take care of multiplication and division, and addition and subtraction. And note here that parentheses and exponents are separated by a comma, but multiplication and division are not separated by a comma. They are separated by a slash, because that means multiplication and division actually have the same priority. They're like one thing. They have the same priority. So the M and the D have the same priority, and similarly the addition and subtraction have the same priority. So if they have the same priority, then you do them in the order in which they appear. So that means if I have something that has multiplication and division, but the division appears first, then you're supposed to do the division first and then the multiplication. Because one and multiplication and division have the same priority, so you do them in the order in which they appear. So for example, 4 divided by 2 times 3, I see a division and a multiplication. PEMDAS supposedly says that you're supposed to do the multiplication first and then the division, but that's not true because M and D, the multiplication and division, have the same priority. So these two have the same priority, so you do them in the order in which they appear. So that means you're supposed to do the division first and then the multiplication. So 4 divided by 2 is 2. So taking care of that, that gives you 2 times 3. So the answer is 6. And same with addition and subtraction. You do them in the order in which they appear. So if you had 4 minus 2 plus 3, then addition and subtraction have the same priority, so I do them in the order in which I see them. So take care of these two. 4 minus 2, that's 2. And then plus 3, that's 5. Okay, so the M and the D have the same weight. So do them in the order in which they appear. And the A and the S, the addition and subtraction, also have the same weight. So you do them in the order in which they appear. Other than that, you follow the order in PEMDAS. All right. And one last thing, when you're entering stuff in the calculator, um, depending on the calculator that you have, if you have a fancy calculator, then this does not apply to you. But if you have a cheap one, this does. If you're entering something in the calculator, such as this, the calculator doesn't know. You see, the numerator is like a group of things. The 4 and the 5, the 4 plus 5, all that belongs to the numerator. So it's like these numbers belong to the top. So this is like a group. The whole numerator is a group. And then the bottom also has a group of numbers, 5 minus 4. But the cheap calculator doesn't know, so you're supposed to put parentheses when you enter this in the calculator, because the calculator doesn't know any better, and you're telling it all of this is the numerator, and all of this is the denominator. So you're supposed to put parentheses when you enter this in the calculator, even if if the parentheses are not originally there. If your calculator doesn't display what you entered exactly like this, then you're supposed to put parentheses. Okay. All right. That's it. Now let's get to the examples. All right. First one, simplify the following. I'm going to do these without a calculator because the whole point is to get familiar with the properties of exponents. So let's start with this one. 2 to the third, that means you multiply by 2 by itself 3 times. So 2 times 2 times 2. You can take the first 2. 2 times 2 is 4. So this is 4 times 2, and then 4 times 2 is 8. Okay, next one, negative 3 to the 4. Negative 3 to the 4 means negative 3 by itself 4 times. So negative 3 times negative 3 times negative 3 times negative 3. Okay, so I can take the first two, negative 3 times negative 3, that's positive 9. Remember that when you multiply two negatives, you get positive. And then I can take so I took the first two, and I can take the last two. Negative 3 times negative 3 is another 9. So this is 81. Negative 3 to the 4 is 81. Now, this one says negative 2 to the third. Note that this is very different from this. When you have the exponent, when you have the negative inside the parentheses and then the exponent outside, that tells you that the negative 3 repeats itself 4 times. So you have to repeat the negative 4 times as well. Here, the negative is not affected by the 3 because it is not included in the parentheses. So really that means the 3 is only touching the 2. So that literally means that only the 2 gets repeated 3 times. Not the negative. The negative is not affected by the 3, by the exponent 3. If it were, it would have to be in parentheses. It is not. So the 3 is only touching the 2, not the negative. Okay, so that's the big difference between these two. All right, and then you do this, and you're going to get negative 8. Because 2 times 2 times 2 we already did at the top here, that's 8, and then you have the negative. Okay, now next, you have this. According to PEMDAS, we're supposed to simplify the parentheses first. So, simplify the parentheses first. Negative 3 times 2 is negative 6. Then to the third. This means negative 6 by itself 3 times. And then note that the negative is included in the repetition because it is inside that parentheses. So negative 6 times negative 6 times negative 6. And this is negative 216. Right? And I usually put final answers in boxes. So I'm going to do that. Okay, now let's do something a little bit more complicated. Now let's include variables. Well, not in the first one, but on the rest. And use all the properties of exponents. Okay, here's the first one. It says negative 5 over 3 to the negative 2. First thing you need to do is simplify the parentheses if there's anything to simplify. Here, there's nothing to simplify because 5 and 3 have nothing in common. So you cannot simplify that. So since there's nothing to simplify, then you move to the next thing in PEMDAS, which is the exponent. So now we take care of the exponent. The exponent is a negative exponent. So, and it is affecting a fraction. So what is the property then? The property is number 9 here. Have a negative exponent affecting a fraction. So you flip the fraction and keep the exponent positive. So I flip the fraction. And I keep the exponent. Okay. One common question that usually arises is why don't you put the negative with the 5? Because if you flip, it should really be positive 3 on top and negative 5 on bottom. But that really doesn't matter. When you have a fraction, if you have a minus like that, this is really the same thing as, okay, that's that. This negative 3 over 5 is really the same thing as negative 3 over negative 3 over 5 or 3 over negative 5. All these things are the same, meaning you can put the negative on the top, you can put it in the middle, you can put it in the bottom. All three ways are exactly the same thing. Usually, though, we put the negative either on the top or in the middle. It is not very common to write the negative, to leave the negative on the bottom. Usually move it to the middle or to the top. So that's why I didn't put here the negative on the bottom, because I mean it's not wrong, it's just not very common. You just move it to either to the middle or to the top. Alright, so that's what I did. So flip, and then the exponent is 2, and now the next property is that you distribute the square, so the top gets the square, and the bottom gets the square. Now, negative 3 squared is negative 3 times negative 3, which is positive 9. And then 5 squared is 5 times 5, which is 25. Okay, how about the next one? Okay, that looks more involved. Okay, let's see. It's not hard though. All right, we have parentheses here. If there's anything to simplify, you would do that. There's nothing here to simplify because you cannot combine u's and v's. They're different variables. So there's nothing to simplify here. There's nothing to simplify here. For the same reason, that's a u and that's a v. You cannot combine that. If you could, you would, but you cannot combine that. All right, so then the next thing is you move then outside of the parentheses to the exponent. Okay, this exponent here, because everything is being multiplied, you can distribute it. Remember, as long as everything is being multiplied, you can distribute it. If there were sums or minuses, you cannot. But there's no sums or minuses. Everything is multiplied. So that means you distribute the 2 over everything. So that means the 3 gets the 2, gets squared. The u to the 7 gets squared. The v to the third gets squared. Everything gets squared. Okay, and then you still have 4 u to the 4, v to the negative 5. Okay, now you simplify each of these. So 3 squared is 9, 3 times 3, which is 9. U to the 7 to the second, that case, you multiply the exponents because the exponents are there back to back. If you had them separate, like u to the 7 times u to the 2, that's when you add them. But here is like u to the 7 to the 2, like back to back. So you multiply them. And then this is same reason, v to the 6. V to the 6, and then times 4, u to the 4, v to the negative 5. Okay, then you combine what you can. You can multiply the 4, the 9 and the 4, you get 36. And then you can multiply u to the 14 times u to the 4. U to the 14 times u to the 4. What's that? U to the 14 times u to the 4. Now that's when you add them because they're separate. That's when you add them. So these would be u to the 18. And then v, now you can combine the v's. V to the 6 and v to the negative 5. You're going to separate, so you add them. 6 plus negative 5 is 1. So that would be v to the 1. But you don't really write v to the 1, you just write v. Really, the final answer, the way you would enter it in your homework, is just like this. You don't have to write v to the 1, just v. Okay, and that's the final answer. Okay, let's do a few more. So here's this one. I'm going to do 6 more. Okay. Oops, where is that? Right, okay, this one. Negative 7 x to the 7 times 2x to the negative 8. Again, start with the parentheses. If you can simplify anything, that's what you should do. Here's just nothing to simplify in these parentheses, so you move to the next thing. Okay, well, in this one, there's nothing to simplify. Here, there's a little bit of something you could do to simplify. So you have, this is negative 7x to the 7, and I could actually simplify that negative exponent by saying, well, what does it mean negative exponent? That means you flip. So this is x to the 1 over x to the 8. All right, so this is negative 7 x to the 7, and then you can write that as a single fraction, simplifying this parentheses, multiply across that 2 over x to the 8. Now, simplify that. You multiply across, this is negative 7, you multiply the negative 7 and the 2, that's negative 14 actually. You get negative 14x to the 7 over x to the 8, multiplying across. This is like there's over 1 here, an invisible over 1. So that's what you get, and then you simplify what you can. These x's you can combine. You have x to the 7 and x to the 8 on bottom. So this would be, what is the property? You subtract. So this would be x to the 7 minus 8. 7 minus 8, subtract the exponent, that would be x to the negative 1. And usually we do not leave negative exponents as a final answer, okay? Don't leave negative exponents as a final answer. That's considered not simplified in most cases. Um, College algebra will say it is not simplified, so don't leave negative exponents in your final answer. So that means then that your final answer, you should write it as negative 14, and then x to the negative 1 means you flip, so that goes to the bottom. And that's the answer. Okay, when you have x's on top and bottom, you can just subtract. Or you can think of it like this way. You have 7 x's on top, 8 on bottom. If you could cancel x's, you have 7 on top, 8 on bottom. You can cancel 7 from both top and bottom, and you would have a leftover of 1 on the bottom. So that's why you have a leftover of 1x on the bottom. That's another way to think about it. Okay. Next one. All right. First, parentheses. If you can simplify the parentheses, go ahead and do that. So let's do that. We can simplify this a little bit. This will be 2x to the 2, and then here you have an exponent back to back. X to the 2 to the 3. X to the 2 to the 3, that would be x to the 6. You multiply them because they're exponents that are back to back. So x to the 6. So that's the first step. We simplified a little bit um, that parentheses. Now, all of this is raised to 0. Anything to the 0 is 1. So you can say this whole thing is actually 1. So times 1, and then times 5 over x to the 7. Now let's keep simplifying. You can simplify this. This is just like we did here above. we can simplify this by subtracting the exponents. So subtracting the exponents, 2 minus 6 is negative 4, but the fact that it's x to the negative 4, you can do that, x to the negative 4 to the negative 2. Then times 1 doesn't do anything, so you don't have to write it again. Now, x to the negative 4 is, you can simplify that negative exponent by flipping it. So it is the same as 2 over x to the 4. And you could have done that in one shot, okay? You don't have to write this and then that. So you could have said, okay, x to the 2 over x to the 6, that would be x to the negative 4, because it's negative, you can just put it on the bottom and save this step. Um, so that's what I will do in the future. All right, next, probably just like 2 or 3 more steps. Next, you have this negative exponent affecting this fraction, so that means that negative exponent flips the fraction, so that means x to the 4 over 2. And once you flip it, you keep the positive exponent. All right, now you can distribute this square over that fraction. So that means the fraction, the top gets squared and the bottom gets squared. Now, exponent back to back, x to the 4 to the 2, that would be x to the 8. You multiply, in this case. 2 squared is 4, 5 over x to the 7. Okay, now we're getting closer. Now, multiply across, this is 5x to the 8, 4x to the 7 over 4x to the 7. And lastly, you can simplify these. You have x on top, x on bottom, so the property of exponents says you subtract the exponents, so it would be 5. You see x to the 8 over x to the 7. You subtract the exponent, that would be x to the 1, so x to the 1. X positive, so that means it is on top. So on top you write x to the 1, but you don't have to write the 1, so you just write x. And that's it. Okay, so that was step by step. And as I said, you can probably save some of these. I just did every single little step. Okay, let's take a look at this one. E, 5x to the negative 1 times y to the negative 4, all that over 3y to the 5th to the negative 2, x to the 9. Okay, for this one, we're going to use this property 10 right here. Okay, if you have negative exponents either on the top or on the bottom, they just trade places. So if you have a negative exponent on the top, it moves to the bottom. If you have a negative exponent on the bottom, they move to the top. We're going to use that here over and over. Okay, so here, x to the negative 1, the x to the negative 1, because the exponent is negative, that x moves to the bottom. The 5 stays, but the x moves down. Okay, remember that negative 1 is only for the x, is only touching the x. If it was affecting the 5, there would have to be a parenthesis. There's no parentheses, so only the x has a negative exponent. So only the x moves down. Only the x switches places. So the exponent, x to the negative 1, that means the x moves to the bottom, and you keep the exponent. So x to the 1, we just write x. The y to the negative 4, the exponent is negative, so you move it to the bottom as y to the 4. So that takes care of the whole top. The 5 stays in the same spot. It doesn't have a negative exponent. The x moves to the bottom because it has a negative exponent, so x to the 1 on bottom. And the y moves to the bottom because it has a negative exponent, so y to the 4. Now, this whole thing, Now let's go to the bottom. This whole thing moves to the top. The whole thing in the parentheses, because the whole thing in the parentheses has negative exponent. So that whole thing moves to the top. So 3y to the fifth squared. And the x to the 9 doesn't go anywhere because the exponent is positive. Only the exponents that are negative trade places. Okay, make sure you got that. So rewind the video if you need to see it again. Things that have negative exponents trade places. Okay, now all the exponents is positive. Now let's apply the other properties. I have this thing here squared. You can distribute the square. So that would be 3 squared, and the y to the fifth also gets squared. And then on the bottom, I'm not going to do anything yet. Just distributed this square over the 3. So that means the 3 gets squared, and over the y to the fifth. The 3 gets squared, and the y to the fifth gets squared. Now, 3 squared is 9. Y to the fifth to the 2 is y to the 10. All that over x. So I'm not doing anything yet to the bottom. You can do that. You can simplify it if you want to. I'm going to do it in the last step. And in the last step, I'm going to combine things. Now, 5 times 9 is 45. And then I can combine these x's. X to the 1 and x to the 9, that's x to the 10. Y to the 4. So all the top is simplified, all the bottom is simplified, but now the fraction as a whole can still be simplified a little bit more because these y's you can combine and simplify that. So if you simplify those by subtracting the exponent, 10 minus 4 is 6. 6 is positive, so that means that stays on top. So y to the 6 on top, x to the 10. If you had got negative 6, that means you write the y to the 6 on bottom because the exponent is negative. And that would be it. That is the end. Okay, now I recommend that you pause the video and try to solve the next few problems. So F and G, you should pause the video and attempt those and then compare notes with me. Okay, let's do it. So you have n to the negative 2, m over 13, m to the negative 4, n to the negative 3. Okay, so things that have negative exponents, switch places. Let's start with the top. On the top, the n squared that's a negative exponent, so that goes to the bottom. Move it to the bottom with a negative exponent. The m doesn't have a negative exponent, so that means it stays on top. It stays put where it is. So that takes care of the top. Now let's look at the bottom. The 13 doesn't have a negative exponent. Okay, remember that negative 4 is only touching the m. It is not affecting the 13, because if it was affecting the 13, there should be parentheses around the whole thing. It should look like this. But it is not. So that means the negative 4 exponent does not affect the 13. That means the 13 does not move to the top. It stays on the bottom. So only the m moves to the top. So the m to the 4 moves to the top. And then the n to the negative 3 on the bottom also moves to the top. So n to the positive 3. Okay, and now combine what you can. I can combine these m's. So that would be m to the 5th, n to the 3rd. And on bottom you would have 13 n squared. Okay, and now you simplify these n's. You can combine these ones. and subtract the exponents. 3 minus 2 is 1. It's positive 1. So the fact that it's positive 1, that means it stays on top. So n to the 1 on top over 13. And again, don't write n to the 1 because we never write that. We just say n. Okay, and that's the answer. Remember that when we had subtracted, we had got a negative number for the exponent. That means you put it on bottom. So if we had got, let's say, if that was a 5 instead of a 2, you would get 3 minus 5 is negative 2. So that means you put n squared on bottom because it's negative. If it's positive, you put it on top. So you should have got that as your answer. Okay, 2 more. Again, you should attempt that one. So you should pause the video and attempt it, and then compare your notes with me. Okay, first, PEMDAS, simplify the parentheses and then take care of the exponent. We can simplify that parentheses. Things that have negative exponent migrate. So if it's on top, moves to the bottom. If it's on bottom, moves to the top. So this t to the negative 5 moves to the bottom. T to the negative 2 moves to the top. And s to the negative 1 moves to the top. Okay, you don't have to write s to the 1, because again, we don't write that. Okay, so that simplifies the parentheses a little bit, but we're not done simplifying the parentheses because we can still combine these t's. So now combine the t's. Subtract the exponents. 2 minus 5 is negative 3. So that will be t to the minus 3. But don't write that because that's not simplified. It's correct, but not simplified. Instead of writing t to the minus 3, it would be better if I just write t to the 3, but because it was negative, I would write it on bottom. So 2 minus 3 is negative 3. So 2 to the negative 3, because it's negative, you put it on bottom. It's positive. That's simplified. Okay, now you have that. Now we can distribute this exponent. That means the numerator gets the exponent and the denominator gets the exponent. So 6 s to the 6 and t to the 3 to the 6. Okay, and now you have exponents back to back. Back to back means you multiply them. So t to the 18. The end, because you can now combine s's and t's. You can now combine s and t's. Okay, that's it. And the very last one. Have another shot at that one. Pause the video and give it a shot. Okay, now let's compare notes. Okay, first, things that have negative exponents migrate. So these would be 24. That 24 doesn't have a negative exponent, so it stays on the top. The a to the third, well, 3 is positive, so it doesn't move anywhere. It's positive. The b to the negative 8, though, that's a negative exponent, so you have to move that to the bottom. So b to the 8 on bottom. Now, the 6, now that takes care of the top. Now let's take care of the bottom. The 6 doesn't have a negative exponent because that negative 5 that I see there is only for the a. It's only touching the a. It only affects the a. There should be parentheses if it was affecting the 6. Alright, so then the a to the negative 5 moves to the top as a to the 5. And then you have the b that doesn't have a negative exponent, so the b stays on bottom. and then you still have that exponent negative 2 outside. Okay, now let's see. You can combine the a's, so you would have, because they're separate like that, a to the 3 times a to the 5. They're not back-to-back exponents like in the other ones, like this. There is a to the 3 times, separately a to the 5, you add them. So that would be a to the 8. And then you can combine these b's, that would be b to the 9. Now again, keep simplifying the parentheses until we have simplified as much as we can. I cannot combine a's and b's, but I can do this, 24 divided by 6, 24 over 6, that is 4. Okay, 24 divided by 6, you can cancel the 6, that is 4. So this is the same as 4 a to the 8 over b to the 9. Divide top and bottom by 6. You get 4 on the top, 1 on the bottom, you don't write the 1. Okay, almost done. Now you have a negative exponent affecting a fraction. Negative exponent affecting a fraction flips the fraction. So this is going to be b to the 9 over 4a to the 8. And then the exponent becomes positive 2. The negative does the flipping. Lastly, you can distribute that square over the top and over the bottom. That means the top gets squared. So we get b to the 9 squared, and then the bottom gets squared. Squaring the top, b to the 9 squared, back-to-back exponents, that's b to the 18, you multiply. And then distributing the square, that means you get 4 squared is 16, and a to the 8 squared, back-to-back exponents, that means a to the 16. And that is the end. There's nothing else.